Let's go through the code part of our project. Uh, we choose to communicate through Wi-Fi with our rover. This enables remote control from anywhere in the world. We achieve this remote control by establishing a connection to the server with the Wi-Fi module on board ESP32. We control the ESP32 from the commands on Blink app. Like we achieve this like our rover will be connected to the Blink server and can be controlled with Blink app on phone. The commands given on phone will be sent to the Blink server, and the Blink server sends those commands to the ESP32, which has its predetermined ID. So we achieve this constant communication uh, with this part of code here. So we install Blink library, and this function enables a loop to constantly communicate with the server, and these are the details of the Wi-Fi to which our ESP32 will connect and establish a connection with Blink server. So mm, Blink, we can toggle switch states on ESP32 on Blink server, uh, but the problem we faced while controlling our rover Blink server is uh, our rover needs six different pins. Our rover needs input from six different pins to achieve four different functions, which are forward, backward, right, and left. But the Blink app allows only five button states to be enabled at a time, and we cannot toggle all those six different states individually if you want to control the rover seamlessly. So um, the reason we need six button states to control our rover is uh, we used LN298 motor driver to control the motors of our rover. We used only a single LN298 motor driver. Uh, so this motor driver can control two motors at a time, two from these two outputs. It has six inputs, out of which four are digital and two are analog. In these two digital inputs, two inputs are there to control the inputs to output 1 and output 2, and other two digital pins are there to control the inputs for output 3 and output 4. So these output pins will decide the amount of voltage which reaches the battery. So if you want to control the speed which can be given through these two analog pins, it reduces the amount of voltage which reaches the motors. So we in total need six inputs to control our rover, and we used only a single motor driver to control all the six motors. We achieved this by connecting all set of motors which have the same sense of rotation to one motor output, and other set which has the same sense of rotation to other output. So we connected all the left set to one output and all the right set of wheels to other output. So if you want to achieve a forward direction of motion, then output 1 and output 2 would be given high and low signal, which will turn the left set of wheels clockwise, and output 3 and output 4 will be given a signal of high and low, which will turn the right set of wheels clockwise. So this will enable the rover to move in forward direction. So as I said, uh, we can only control four button states from the Blink app. So we used a feature called virtual pin, which can be toggled from Blink app and can be recognized from ESP32. So I have uh, we have used four virtual states for four directions of motion to our rover. So when we toggle virtual state 1 on the Blink app 104, then it sends the information to server, and the server will toggle the virtual state 1 to high. So in the code we ran a loop which will constantly detect the states of those virtual buttons. So when it identifies virtual button 1, we coded for the following functions to run. Like for we associated virtual state 1 to forward direction of rover, so motor 1A and 1B will go high and low, and motor 2 and 2B will go high and low. So which will enable the rover to move in forward direction, as all the wheels will turn in the same sense. To achieve backward direction, we used virtual state 2. In this state, we coded for the output 1A to go low and output 1B to go high and output 2A to go low and output 2B to go high, eh, which will enable the rover to go in backward direction, or as all the six wheels will turn in anti-clockwise direction. To turn the rover, uh, we used we to turn the rover, we made all the left set of wheels to turn in one direction and all the right set of wheels to turn in the uh, opposite direction of the left set of wheels, so we can achieve turning. So to turn right, we made all the left set of rovers to turn anti-clockwise and all the right set of rovers to turn clockwise. So we gave the following states of the outputs, like output 1A should go high and output 2B should go low, and 2A should go low and 2B should go high. And to achieve the uh, left, we gave the following functions: output 1A should go high, output 1B should go low, and output 2A should go high and output 2B should go low. This will enable the left set of wheels to turn clockwise and right set of wheels to turn anti-clockwise, and our rover can turn left. uh, the the latency of our controls are purely defined by the Wi-Fi speed. If faster the Wi-Fi, the lower the latency, and this enables connecting to an external server enables us to control the rover from any part in the world which has an internet connection. So this is the code and control part of the rover. Thank you.